Hi everyone, Ray Poynter here, and welcome to the next installment of Finding and Communicating the Story. And we're going to be looking at visualization for use in finding and communicating the story today. So let's just move on to the housekeeping while people are logging on, I see. So first of all, a big thank you to our sponsors, our platinum sponsors, Zappy Store, Question Pro, Saros, Mesh, Korea, Dub, L&D Research, Happy Thinking People, SSI, Focus Vision, and Research Now. Without the sponsors, it'd be really difficult to do all of this. There are a variety of background costs. There's admin costs, there is the license for the GoToWebinar and pieces like that, and a combination of the sponsors and individual donations make it possible for us to keep this running. So big thank you to them. If you get the chance, it would be absolutely fantastic if you were to visit their website. So we've got about a 45-minute presentation here today. At the end of that, we'll take questions, and we're just using the GoToWebinar platform for the questions today, so we can consolidate it all into one place. So please use that. And the slides and recordings from today's broadcast will be available soon, hopefully tomorrow. And the slides and recordings from the 4 earlier lessons are also available. So let's have a look at finding and communicating. So this is lesson 5 of 6. Getting very close to the end now. We have one more, which is solely on communicating, reporting the story in the data. But today we're going to look at 2 aspects: visualization for finding and visualization for communicating the story. So just a quick reminder of where we've been. We've had an introduction and an overview, working with qualitative information, working with quantitative information, working with multiple streams and big data, and today it's visualization. So the agenda, very quick recap on a couple of the basic ideas that I've been talking about throughout this broadcast. The difference between finding and sharing in terms of visualization. Then I'm going to start off with making numbers more visual before we move into a wider relationship of visualization and data, and then a few thoughts about the communication side. So first of all, the recap. Frameworks. Everything has to start with defining the problem properly. If we've defined the problem properly, it is half solved. We know what we're looking for. We're asking questions like, what is already known? We need to find out what is believed and what the expectations are before we do the analysis, really before we design the study. We've got to organize the data to be analyzed, and that is a very systematic process, making sure that we are looking at apples and apples and not apples and oranges or apples and pears. So there's a lot of work has to go in at the beginning to organize, structure, error check, reorganize the information. And then we're going to apply systematic analysis processes. That allows us to extract and create the story. This is, I think, a really important thing when you're looking at visualization tools, when you're looking at visualization methods, whether that's Tableau or Excel, whether that's something like SPSS, or whether it's the R language. Most of the steps you use in finding the message in the data are not part of the communication. Don't show everything that you expect that you found on the way. That's not part of the curation process. You're there to take all these parts and make a new story from them. So, for example, most of the graphics you use when you're finding the story will be incredibly accurate. The final story you tell doesn't have to be accurate in the details. It has to be accurate in the story. So you may well position the labels by hand in order to make it even clearer what the story is. But you won't be doing that when you're finding the story most of the time, not because you actually need hyper accuracy, but because it's faster simply to work with the material as it comes. Sometimes none of the visualization that you use is going to be part of telling the story. It can be as strong a case as that. Finding is all about asking the system, asking the tools, asking your processes to show you all the contenders for the main story, and I will choose one. I want to be given lots and lots of options. I want to be given alternative perspectives. I want to see alternative stories, and I will choose one. Because the communication is about telling one story. Here is the story I want to tell you from this information today. When you have a different question, I may tell you a different story from the data. I may tell you a big one, I may tell you a small story. We may have one to do with the green side of the data and another one to do with the technology side of the data. I'm only going to tell you one story in one presentation or one answer to your question. So finding is about producing multiple stories, and communicating is about telling a single story. So there are different uses of visualization. The first use of visualization that we're going to talk about is finding the story in the data, and the second one is telling the story. But there are many other uses. We use it for monitoring. For example, dashboards. Dashboards are not great at finding the story, but they are great for monitoring performance. Are things better or worse than they should be? Think about how you drive a car. The dashboard is telling you what speed you're doing. It might be telling you how many revs you've got. Well, it will be, but you may or may not be looking at that depending on what sort of driver you are. It will tell you if you're running short of gas. It will tell you a whole variety of things. But it doesn't tell you where you should go. It doesn't tell you about the journey. It doesn't tell you how much you're enjoying it. It doesn't tell you a whole variety of things that are important. So dashboards are about monitoring, and they are a great use of visualization. We might want to do a workshop where we do a discovery of findings, and we're going to provide a whole range of visualization tools for people to do that. And that is a great use of visualization, but it's not a single story. Teaching. Imagine you're teaching the geometry of the circle. You're going to be using visualization. You're going to be using protractors and compasses and all of these sorts of things. It's a very different use than we are putting it to in the market research world when we're telling a story. Allowing self-discovery and story creation. So some of the infographics I'm going to show you near the end of the presentation are going to give you the opportunity to let the audience discover features and findings. But they're not the same thing as telling a single story, so they're not the core of what we're talking about today. And of course, instructions. How to build furniture from IKEA is all about great visualization. When it's right, you know how to build the furniture. When it isn't, you don't. But again, that's different sort of visualization. So we're only going to cover a couple of types, and we need to think about all the others. Here's a great example of the sort of visualization I almost never use in a presentation. I have one or two clients who like radar charts, and with them I use them. I will often use a radar chart when I'm trying to find the information. It's a quick, efficient way, if you're familiar with them and you're familiar with the data, of getting to the answer. But they're not a great tool for most clients. So the tools we're using to find are not necessarily the tools we're communicating with. There is a single super book on this topic. Andrew Ehrenberg, A Primer in Data Reduction. It's astonishingly expensive for a small paperback. It's about £80, what's that, about $120, or maybe that'll soon be $80 the way the pound is going. It is an expensive book. It's a great read. It will really help you understand the process of data reduction, because visualization is all about data reduction. We're trying to take the key elements and make them really visible. And when Michelangelo was creating the David statue, they asked him, how do you know which bits of the statue? He said, it's great. It's really straightforward. I just remove all of the stone that is not David. And that is what we're trying to do when we're doing data reduction, when we're doing visualization. We're trying to remove things that are not the story so that we can really see that story clearly. A lot of the time that will come down to getting the right level of detail. So optimizing the detail. This is a self-portrait, but when you see it full size, it's really hard to see what it is. When you see it the size you can see it on your screen, it's still not great. If we reduce it, it becomes clearer. So it's not always about getting closer to the data. Sometimes it's moving back from the data, sometimes it's moving in on the data. So I'm going to start with talking about making numbers more visual. We're going to move on to genuine graphics in a moment, but we can actually make our numbers more visual. The first most important thing is using 2 or 3 significant digits. We usually use, or we often use, too many digits. Then we can use sorting, we can use indices or indexes, as some people call them, and color coding. So let's look at a practical example. Here is some really horrible, really useful data. Per capita government spending on health, it's in dollars. The source is Gapminder. I'm going to talk about Gapminder quite a lot. If any of you have seen Hans Rosling give a TED video, he is using Gapminder data. Gapminder is a set of data and it's great interactive software. So this is 183 countries from 1995 to 2010, and it's how many dollars the government spends on health per person in the country. And it's just a sea of numbers. It makes very little sense to us. So the first thing we can do is we could say, well, let's look at that in 3 significant digits. So we multiply, we divide everything by 10. So we're showing it in units of $10. That means we hide all the decimal places. We don't delete the decimal places because we might want to do some arithmetic functions, but we hide them because they really don't help us. Now, all of a sudden, visually, we can see which are the big numbers. We can see that Albania has very small numbers, $5 or $50 in 1995. If we go down, Andorra, 95. Go down the page, you see United States, $168 in that column B. So all of a sudden, visually, some columns only have a single digit, some have 2 digits, some have 3 digits. And that is more important, the 1 digit, 2 digit, 3 digit, than the content of what those numbers are. That gives us a sense of scale already. The next thing, and this is if we're doing it in Excel or if we're doing it in SPSS, we want to have the ability to sort those columns. So just turn on data filter if you're in Excel. Now I can sort this data by 2002, 2004, 2006. I can keep resorting it. I've added an ID column at the right so I can go back to my original order. And here I've sorted it by 2010 is the year I'm sorting on, the biggest number at the top, the smallest number at the bottom. Sorting is one of the main techniques you will use to visualize data. It doesn't matter whether you're bar charting, graph charting, tree maps, whatever it is, sorting is likely to be at the heart of making the data make sense. So here we see that the countries that spend the most, Luxembourg, Monaco, Norway, United States, drop to the bottom of the league. We have Guinea, Eritrea, Bangladesh, Guinea-Bissau. So we start to get a bit of a picture of what's going on. Let's have a look at the spend data and just chart it. Now, you don't need to read the labels because this is a visualization early stage. And what I'm looking at is the shape of those blue bars. And what we can see is up to about the Slovak Republic, which is 1, 2, 3, 4, 5, 6, 7, 8 in from the right in terms of labels. The curve goes up pretty smoothly, and then we start to see some step functions where it suddenly jumps up, and it suddenly jumps up when we get around the United Kingdom. Those are going to be interesting places to go and have a look at the data. Where it's a nice smooth curve going up, it's unlikely we're going to find an interesting story. But whenever there is a step function going on, it's quite probable that we will find something interesting. What we're looking for here is, are there any step functions? How can we find out what might be really interesting? Where the curve moves up smoothly, it's unlikely we're going to find anything particularly interesting. But where it suddenly jumps, like it does near the Slovak Republic, like it does near Australia, like it does near United Kingdom, it's quite possible we'll find something interesting in the data. So the next thing we can do is we can index the data. Now, when we index the data, we say, let's set 1995 to 100. For every single country, let's set the 1995 data as 100 and see what happens to the data. We can still sort the data and rank the data in different ways, and we can have a look at what patterns are happening. And here is a chart that you certainly wouldn't use with a client. Um, it's every single line, 183 lines of data slapped on the page, and it's showing the index at 100 in 1995. And the reason I do this quite often is to look at the outliers. So we can see the data there for NewMR. It really jumps in 2001. So I'm wondering, is that good data? Have I got a data problem? I look at the background information. Turns out that NewMR has got a population of about 2,000 people. So maybe it's not comparable data. Actually, maybe there was a big investment by somebody in 2001. We look at those other countries and we can run through them just to check that those potential outliers. And many times when I've run this on a data set, I've found either something interesting or a real problem in the data, which is also, of course, interesting. When we use these tools, even the basic things I've just been showing you, you need to find answers to questions. You can't just find answers. Using visualization to find answers, you need questions. So if we take that data from Gapminder, we might have the question, does expenditure on health vary by wealth or politics? So this now is a more complicated piece of visualization. It's from the Gapminder tool, and I'll talk you through some of the pieces. The vertical axis on the left is government health spending per person, which is the piece of data we've been looking at so far. Across the bottom, we have income per person in GDP per capita. So we know how well off people in that country are, and we know what the government expenditure on health is. The countries are color coded, so all of the countries in the Americas are green. Africa is blue, Europe and North Asia is, well, Europe and Russia effectively are yellow, Asia and Oceania are red. And if you're running the tool live, it will throw up, you can put the cursor over, say, this button, and it will tell you Saudi Arabia. This large green circle up the top of the page is the United States. The size of the circles is the size of the population. So now we have 2 or 3 different pieces going on. We have a vertical axis, which is how much is being spent on health. We have the horizontal across the bottom saying how well off are people in that country effectively, on average, not individually, on average. And the size of the bubbles show us where India and China are, those 2 red circles. We see Africa at typically, in most cases, lower income on the left-hand side, and we can see the Americas, we can see the United States. And if we look at this, the first thing we're doing as a visualization step to try to find a story is what does not lie on the leading diagonal? Because clearly, overwhelmingly, the richer people get, the more there is government health expenditure. And that is a really strong pattern. So anybody that sits on that line is not so interesting when we're looking for the story. What is interesting is somewhere like Saudi Arabia and United Arab Emirates, Bahrain, and some of these countries here who have less government expenditure on health than one would expect from the level of income in those countries. And the other interesting bit of the story here is down in Africa, where we have some very low income countries, the amount being spent by the government in absolute terms is higher than we would expect on the leading diagonal. So we've got potentially a story going on there and potentially a story going on just here that we would then pursue and follow. Now on the next chart, what I've got is total health spending, not government health spending, but total health spending and how rich the countries are. And now the diagonal has become stronger at the bottom end. So these African countries have fallen back into line, which suggests that they are clearly over-indexing in a very helpful, positive way in terms of government expenditure, possibly partly funded by aid. We have some countries that are underperforming. We have, again, up here, we've got Saudi Arabia and some of the similar countries there. But we also have an interesting story about the United States. The United States is now slightly above the leading diagonal. The total amount of health expenditure in the United States is higher than you would imagine it would be from its overall wealth. Its government spending is about on par, it's about on the leading diagonal, but when we take total health, personal spending as well, it is spending more than anybody else. It's spending more than some countries that are richer than it on a per capita basis. Turning this around, we can look now at some other factors that are going on. So we keep total health spending on the left-hand side. So this is part of how we're using visualization to find out what's going on in the data. But we change the bottom one to child mortality rate. So further to the right is bad. That's more children dying. Further to the left is good. And now we see, again, which countries are not on the leading diagonal. We see that South Africa is not on the leading diagonal. It has more child deaths than we would expect for that level of government expenditure. Bangladesh has fewer child deaths than we would expect for somebody at that level of expenditure. At that level of expenditure, Bangladesh might be expected to be all the way over here. So that is great. We see United States with more child deaths than we would expect for that level of expenditure. And this is how we use the process to explore the data. Okay, let's switch to brand attribute data, classic sort of market research. We've got brands down the side, we've got some attributes across the page, and we've got the percentage of people agreeing. We've got a really large sample, so we've got lots of decimal places. So we can use conditional formatting. Lots of tools have got this. Excel, of course, is the most famous. You can just say highlights using color. So the bright green colors are the big numbers, and the darker red they are, the smaller they are. So now all of a sudden, I can see that brand 7 is really low on stylish and pretty low on sexy. So just by doing that, I start to get some visualization sense. We change that to 2 significant digits, so let's get rid of all those decimal places. It becomes a little clearer. Diagonalise. This is, it's like sorting as a concept, but it's more powerful. I want to group together areas of the data that seem similar. It's a little bit like clustering or segmenting as well. So we've diagonalized the data, and now we can very quickly see that we've got 2 types of attributes. Sexy, strong, stylish, traditional go together. Friendly and cheap go together. We've got 4 brands 4, 5, 2, and 3, which are associated with being strong on sexy, strong, stylish, traditional. And we have a couple of brands, well, 3 brands 1, 6, and 7, that are strong on friendly and cheap. So brand 1 is a bit of a switchover brand between the 2. So just by diagonalizing the data, we've got a much clearer picture of what's actually happening in our information set. We really don't need those percentage signs next to every single number. Look how much cleaner it becomes if I take them off. And the next step is to say, actually, I don't need 2 significant digits, with the exception of the 10s. Let's go for 1 significant digit. Now we have something that is really easy to see. Now, of course, when we present it, we wouldn't use it exactly like that. We would be developing the story. In fact, we're probably not going to use tables in our presentation at all. But this sort of technique will enable you to find the information better. So to use analysis to find answers, we need questions. To use visualization to find answers, you need questions. So how does income relate to life expectancy? I'm going to take several pages from the Gapminder website, and I urge you to visit it yourself. And so this is from a story that Hans Rosling is telling about how does income relate to life expectancy? Short answer, rich people live longer. So that is what we mean by telling the story. There is a very clear story. There are some other nuances within it, though. So this is the lifespan up the left-hand side. We've got income along the bottom. The graph shows income and lifespan. Each, the world today, each bubble is a country. So color region tells us that the greens are the Americas and the blues are Africa and so on. We can do exactly the same thing with these are brands' strengths, the number of people who like a brand, affiliation, concepts over time. We can use the Gapminder methodology to help you look at and visualize information. So there are the Americas. The size of the bubbles are the size of the population. So that's China. Further down we have India. These countries have the lowest income and the shortest life expectancy. So all of these countries, mostly Africa, but there are some in the Americas and in Asia down there as well, not much money, short life expectancy. At the top end, all of the rich countries have a high life expectancy. So we have a lot of consistency at the bottom end. If you're really poor, life expectancy is short. Or if life expectancy is short, you're really poor. We have to be careful of both interpretations. If you're high income, long life expectancy. Long life expectancy, high income. What he then does, because he's now communicating as opposed to finding the story, he draws this on the page. There are no countries here. There are no rich countries with a life expectancy below 74. And he draws another box over here. There is no country that is poor and has a life expectancy above 64. It's not just about gross national happiness for some people who talk about alternative ways of living. If you are poor, life expectancy is lower. And he then goes on to make the point that in the middle income group, there are huge differences. And that's from 50 years to 75 years. And that depends on how the money is used and distributed. So if you're rich, then you have great life expectancy on average. If you're poor, then you have terrible life expectancy on average. But if you're in the middle group, which is where most people are, then it depends on what you do with it. So we now have the nuanced version of the story. Hans Rosling found the story using data. Rich countries, long life. Very poor countries, short life. But in most countries, the middle group, it depends on how the money is spent. And he then uses charts to tell the story. But the story is not the charts. The charts are just a device. He picks a subset of the hundreds of charts he looked at in order to tell that coherent story. This is all about the Gapminder and the site. This is in the deck for your reference. So we should always be looking at different perspectives. Is that caused by low income or is it caused by short life expectancy? Quite often it will be caused by both. If we're trying to explain something, we always need a comparator. I've spent tens and tens of hours looking at videos this year about visualization and methods of communicating, and the single biggest message that I hear in those recordings and lessons is that to show something, you need a comparator. So here's a comparator. Someone's finger and a radio frequency identifier, the RFID chip that we use in devices, and that's how small it is. Now I can understand how small it is. We've got lots of concern about Zika, so I did a Google search, and sure enough, there's a really high spike about Zika. Is it really high? I need a comparator. So I look at interest in cancer over time. Okay, that says to me that Zika spike is pretty high because it comes up at around the cancer level. Now I put Ebola on the chart. Okay, for a real hot concern, Zika is high, but it's nothing like as high as Ebola. I'm starting to get a sense of what these numbers mean because I'm using comparators, and I'm using comparators that I consider to be relevant. So I've got a chronic condition like cancer. We've got an acute crisis like Ebola, and between them they make a comparative set. Here is a great example from Eurostat. So they've sorted the data. So just explain briefly what it is. Amenable deaths, people who need not have died. If the right interventions had taken place, they need not have died. They're amenable, they're avoidable deaths is another definition, which is slightly different. So this data has been collected. Fantastic amount of background work must have gone on to organize this data because it's going to be collected slightly differently in every country. So they've had to normalize that to get it on a constant basis. They then sorted it from the worst country on the left, Latvia, through to the best country on the right, France, and then they've added some non-EU comparators to the right of that. And then we've got another comparison going on. They've separated the data for men and women, and we get this really clear picture that from about Poland left, we are seeing some really significant differences and some really high values for amenable deaths amongst men. So all of that is visually very powerful. It's straightforward. And what's more, we're not really interested in what the numbers are. There are 1, 2, 3, 4, 5 numbers on the left-hand side of the page, but you don't need those numbers to see where the problem is. The problem is that men are dying more unnecessarily than women, and they're dying in particular in Eastern Europe. All of that jumps off the page. Once you've got the story, you can then go and look at the detailed numbers and produce quantified statements about the cost of lost lives is this, the cost of treating it would be this, and so on. But the story is visually off the page. When you're using visualization, numbers should not matter. If you look back at those pages from Hans Rosling and Gapminder, there are almost no numbers. What we're looking to do is to get them right. If we find we have to add numbers back onto the chart, we're not really doing the job, or we're trying to do more than one job with that chart. So comes back to numbers. Let's try to use numbers for illumination when we use them and not just for support. Here's an example again from the Gapminder data. Almost no numbers, but it's incredibly clear. It tells its own story. Here's another example from Seth Godin. No numbers. Death rate per watts produced. Coal, oil, nuclear. He's telling a story. He's saying that we should not be worried about nuclear, we should be worried about coal. However, this also represents an enormous power shift. When we use visualization as a communication device, which is what we're doing here, as opposed to an analysis device, we take power away from the viewer, from the listener, from the audience. We give power to the storyteller. We're telling one story, we're telling it very convincingly, and we're not providing the ammunition for alternative interpretations of the data. That is what our clients mostly want, but we should be aware of the danger, and clients should be aware of the danger, and the data should be made available in the backup set, because really high quality visualization represents a massive power shift from the audience to the storyteller. Here is the same data that Seth Godin was talking about, and you can see why that would have much less impact if you presented it. There are lots of sources around of infographics, and I would certainly urge you to go and have a look at them. David McCandless information is beautiful. One of the things you will notice is that it tends to be fashionable. So for a while, lots of people were using these people charts. And actually what is powerful about this particular people chart is the little whimsical remarks, the dead, the lazy, the loudmouths, more than some of the visual pictures within that. So if you're one of the first people with your audience to use these people, 100 people as a method of showing proportions, that's great. You don't want to be the 25th person to show them this sort of infographic. You can be the 25th person to show them a bar chart or a line chart, but the 25th showing a tree map, or which is this like the BBC $1 Million-ogram, or these sorts of charts, actually looks like you're not very cutting edge. So it's a difficult thing to balance. This is a really interesting visualization. It shows languages around the world. It's used the concept of a globe, and then it's grouped all those languages. And then it tells us a little bit of how it groups them. Now, there are all sorts of scopes for arguments about the numbers within some of these, and what do you mean by first language, and is it appropriate to group together all of those versions of Chinese when we're counting some other languages like Spanish and Italian as separate languages, which have bigger differences. That doesn't really matter. What we've got is a very impactful thing that's passing the message that the person who produced it wanted to pass. However, this is an infographic that allows the reader to find a story. It doesn't tell a single story. It tells many, many stories. If I use this in a presentation, I would probably build it over several different screens. I would have to devote a lot of time to how this was helping me tell the story, because I'd need to know what the story was, and then let this diagram outline it. A lot of planning and organization. As a standalone infographic on a wall, in a classroom, on the internet, it's fantastic. But it's not necessarily something we would use in a presentation, even though it's fantastic. Here's another example. Similarly, this is Google's music timeline. It's interactive. You can click on it. It can make things come alive. It's a great use for people wanting to discover information, because if you click on pop in the 90s, 60s, you get 1960s band. If you click in the 2000s, you get 2000 bands. Alternative indie, you might wonder, well, what exactly do they mean by that? Well, you click into it, you'll see which bands it is. That is great as a discovery tool. It's great as a method of just diving into the data and swimming, probably not to find the answer to a question, but just to enjoy the experience. Usually it's not a great tool in a presentation to communicate a story, unless your story is really something quite fundamental, like the decline of rock over the years. That alternative indie came and has nearly gone, or something like that as a story, then you could use this as background. But beyond that, whilst this is a fantastic infographic, a lot of fun, it's not a method of communicating a story in most cases. Audiences can be trained, but not quickly. And this comes back to radar charts. If you have an audience that is used to reading radar charts, then they have been trained. If you talk to financial audiences, they're often very familiar with these box plots and whiskers and where things are moving on the stock exchange. And that is great. If you've got an audience who has been trained, then work with what they know. This is probably the most important academic science diagram there is. It's a fantastic visualization for some people. It's called a Feynman diagram. Feynman was a Nobel Prize winner, an American physicist, super genius. And before him, as you can read on the right-hand side, the interaction of subatomic particles can be complex and difficult to understand intuitively. A simple visualization replaces rather arcane abstract formula. But to most of us, that is meaningless. If anybody is interested, it's on this left-hand side, we've got an electron and an anti-electron annihilating each other, producing a photon, which is the sine wave, producing a quark and an anti-quark, and spinning off a gluon all across time. And the arrows are which ones are moving forward in time and which ones are moving back in time. But it's meaningless to most of us. So you need to work out whether or not you can train the audience, whether the audience has already been trained to use this new type of chart that conveys more information in your particular field. Some people in advertising tracking have developed some really nice charts to do with the ad spend and the impact, but they're only relevant if they're being used with a trained audience. So the big picture. Visualization for finding the answer is usually different from telling the story. The key is data reduction, the Michelangelo way. Remove the stone that is not David. In a visualization, numbers should be largely irrelevant to the communication. So you may have numbers in your analysis stage, and you need to know the numbers, and the numbers need to be in the background information. But if you are using visualization well, the numbers should be largely irrelevant. Visualization should match or stretch the audience, but not be out of their quick grasp. So many audiences like it if they have to work a little bit harder than usual to understand this information because it's in 2 dimensions or it's using color or something like that. But if it's more than just a little bit harder, you will lose that audience and they will say, oh, really wasn't very good. So we've got to find that balance. And that means researching your audience, which is true for every element of communicating a story, not just the visualization element. So with that, thank you very much. Please remember to follow us on Twitter, sign up to receive our newsletter. And I will turn back to the question screen and see what we have.